Seventh grade honors, we're doing transformations. Remember, we're working on four different types of transformations, but this one's going to be on reflections today. A reflection turns a figure over a line of reflection. It turns it over a line of reflection in order to create a mirror image. Each reflected point of the figure should be the same distance from the line of reflection on the opposite side. Highlight and identify the line of reflection in each of the examples. So this image right here, it gets flipped over the line of reflection. And what was that line? That's this one right here, also known as the x-axis. And this shape right here, this figure gets flipped over this line, which is also known as the y-axis. Excuse me. Reflect the figure shown over the y-axis. Record the coordinates of the pre-image and the image. I went ahead before the video and I just recorded the coordinates of the pre-image, which is right here. And then we are also going to put on the image. So after transformation, it's going to be, we are 2 spaces from the y-axis. So I'm going to count 1, 2. And down here, it's going to be the same thing also, 1, 2 spaces from the y-axis. And then this one, we are 7 spaces from the y-axis. So I can go to -7. And you see how I'm just making the mirror image across the y-axis? And you could do the same on your paper. Okay, and how do we label this? We use a W prime, looks kind of like an asterisk, Y prime, and then an X prime right here. So we can record the coordinates of the image here. So for W, we have -2 and 6. For X, we have -7, 4. For Y, we have -2, +2. Okay, describe any patterns found in the ordered pairs. Okay, so let's look at the pre-image and what it became. What do we notice with the numbers here? It looks like all the Y values stayed the same. Y values stayed the same. And the X values changed signs. X values changed signs and became their opposites. Running out of space here, but opposites. Okay, hope I spelled that right. How can we represent this algebraically? This is going to be just a simple note that the x's changed, meaning -x, that means they changed to their opposites. And the y values stayed exactly the same, so we just write -x, +y. X values changed, and the y values stayed the same for this one. Let me do the light dance. Give me a moment. Let me just fold this in half. Okay. Reflect the figure shown over the x-axis. Record the coordinates of the pre-image and the image. So pre-image is recorded, and the image after transformation will be here, and then we got to go up to +7. And for here, we're going to go up to +7, +7. Okay, and now we just connect our dots. And we have our image. So this right here is going to be D prime. This will be F prime. And this will be E prime. All right, record our coordinates here. For D, we have +2, +2. For E, we have 7, 7. And for F, we have 2, 7. Okay, class, so describe any patterns found in these ordered pairs. What do we notice? What happened to the numbers here? And looks like we have the same numbers, but the Y values change signs. So Y values changed signs to become their opposites, right? The Y values changed their signs, became the exact opposites of what they were. And we could put X values stayed the same. How can we represent this algebraically? Again, we can put the X values were the same, so we'll just write it X. The Y values changed to their opposites, so we'll put a -Y. Okay, as simple as that. All right, so that's the entire first half. And is there anything that needs some explanation here? It looks mostly like more of the same, so go ahead and work on this on your own, and then let me know if you have questions while you're in class. Thank you.